Welcome to an exploration of one of the most powerful forces on Earth, fire. In this video, we'll dive into the science of fire, uncovering what it is, how it ignites, and the many ways it shapes our world. Fire is both a tool and a force of destruction, essential for survival and fascinating in its complexity. Join us as we uncover the mysteries of fire and learn what makes it burn, spread, and transform everything it touches. Fire is one of nature's oldest and most captivating phenomena. Its presence has both nurtured life and, at times, threatened it, becoming a symbol of transformation, power, and mystery. For thousands of years, humanity has relied on fire for warmth, cooking, protection, and even in spiritual ceremonies. Our ancestors first discovered its potential when lightning or volcanic eruptions ignited natural fires, showing us that under the right conditions, fire could be controlled and used as a tool. The evolution of fire-making was a milestone in human history, marking the beginning of our journey into science, technology, and civilization. But what exactly is fire? At its core, fire is a chemical reaction known as combustion, a process that occurs when a fuel source combines with oxygen in the presence of heat. This combination leads to a chain of events that produces light, heat, and the characteristic flames we associate with fire. The reaction involves atoms and molecules exchanging energy, creating visible flames and releasing energy as heat. Fire is unique in that it exists in a state between solid, liquid, and gas, often called plasma. This energetic reaction gives fire its mesmerizing flicker, as different parts of the flame emit various wavelengths of light. A closer look reveals that fire needs three essential elements: fuel, oxygen, and heat. These components make up the fire triangle, and all three must be present for fire to ignite and continue burning. Fuel can be anything from wood to gasoline, essentially any substance that can release energy in the form of heat. Oxygen, typically from the air around us, acts as a supporter of combustion, allowing the chemical reaction to take place. Heat, either from a spark, friction, or another source, is what initiates this reaction, providing the energy needed to start the combustion process. The burning of wood, one of the oldest known fuels, illustrates the process of combustion. Wood is composed of carbon, hydrogen, and oxygen, and when it's heated, the molecules break apart. As the temperature rises, volatile gases are released, reacting with oxygen in the air to produce flames. The yellow-orange glow of the flame is due to the tiny carbon particles being heated to incandescence. When we burn wood, we see three main stages: drying, pyrolysis, and combustion. First, the moisture in the wood evaporates. Next, the wood breaks down into simpler compounds through heat, pyrolysis, and finally, these compounds react with oxygen to sustain the flames. What's fascinating about fire is its ability to sustain itself through a feedback loop. Once combustion starts, the heat generated keeps the reaction going, creating a self-sustaining cycle as long as fuel and oxygen are present. This cycle makes fire one of the most effective tools for heat production, but it also makes it potentially dangerous. The intense heat and energy of fire allow it to spread rapidly, transforming anything in its path. Fire behaves differently depending on its environment. In an open space, flames may flicker and rise vertically, while enclosed fires, like those in stoves or fireplaces, can burn steadily. Fire also varies in color, depending on the temperature and the material being burned. A low-temperature fire might produce a red or yellow flame, while a high-temperature fire can produce a blue flame, as seen in a gas stove. The color of a flame is a clue to its temperature and chemical composition, giving scientists and firefighters valuable information about the fire's nature. Beyond its physical properties, fire plays an essential role in many ecosystems. In forests, for instance, fire is a natural force of renewal. Wildfires clear out dead vegetation, making room for new growth. Certain plants even rely on fire to release seeds as the intense heat opens their protective coatings. In these environments, fire maintains biodiversity and nutrient cycles, contributing to a balanced ecosystem. However, human interference, climate change, and land use practices have made some fires more destructive, leading to prolonged fire seasons and devastating wildfires in some regions. For centuries, fire has also been a cultural and spiritual symbol. Ancient cultures revered it as a gift from the gods, often associating it with life, transformation, and even immortality. Fire ceremonies and rituals are found across the globe, from the Olympic flame to the Hindu festival of Diwali. These rituals reflect humanity's deep respect for fire's dual nature, both constructive and destructive. Modern society's use of fire extends to virtually every industry, from metallurgy and manufacturing to power generation and space exploration. Fire or combustion processes are integral. The engines in our cars and the turbines in power plants rely on controlled combustion to generate energy. Even rocket engines use combustion, mixing fuel and an oxidizer to create the force needed to lift spacecraft off the ground. Fire's energy is harnessed in numerous ways, fueling innovation and driving technological advancements. Despite our control over fire, it remains a force that can sometimes elude our grasp, leading to accidents and natural disasters. Uncontrolled fires, like house fires or forest fires, demonstrate how quickly fire can spread and how challenging it can be to control. Firefighters use their understanding of the fire triangle to combat flames, removing one of the essential elements, such as by cutting off oxygen or cooling the fire with water, to extinguish it. Understanding fire's nature is critical in preventing and responding to fires, helping protect lives, property, and the environment. In recent years, fire science has expanded, particularly in response to global warming and increased fire incidents worldwide. Researchers study fire behavior, exploring how different materials burn and how environmental factors influence fire spread. This research has led to innovations in building materials, firefighting techniques, and even fire-resistant crops for agriculture. The goal is to reduce the devastating effects of uncontrolled fires while maximizing fire's benefits in controlled settings. On a larger scale, fire has played a role in Earth's geological history, influencing everything from climate to species evolution. Volcanic eruptions, which are essentially natural sources of intense fire, release gases and ash that can affect global temperatures and weather patterns. These eruptions have shaped landscapes, created islands, and, in some cases, led to mass extinctions, underscoring fire's profound impact on Earth's history. In space, fire behaves differently due to the lack of gravity. Flames in a microgravity environment, like on the International Space Station, form spherical shapes because hot gases don't rise as they do on Earth. Studying fire in space has given scientists insight into combustion processes, potentially leading to advancements in energy efficiency and safety in space travel. The study of fire in zero-gravity conditions provides valuable information for designing fire prevention and safety protocols for future space missions. In essence, fire represents both the potential for creation and the risk of destruction. Our understanding of fire has allowed us to harness it for warmth, industry, and exploration. But it has also taught us respect for its power. As we continue to study and utilize fire, we balance its benefits with a profound awareness of the responsibility it entails. Whether as a tool or a natural force, fire remains a central element of life on Earth, an enduring symbol of energy and transformation that connects us to our planet's past and propels us toward its future.